Hi, this is your Professor Sudha Kolathu Parambil, section 11.3, hypothesis test for the difference between two means, paired samples. I'm going to explain to you how to perform a hypothesis test with matched pairs using p-value method and the critical value method. So let's look at the p-value method. Does tuning a car engine improve the gas mileage? A sample of 8 automobiles were run to determine their mileage in miles per gallon. Then each car was given a tune-up and then run again to measure the mileage a second time. The results are presented in this table. The sample mean mileage was higher after tune-up. We would like to determine how strong the evidence is that the population mean mileage is higher after tune-up. These are paired samples because each value before tune-up is paired with the value from the same car after tune-up. By computing the difference between the values in each match pair, we can construct a sample of differences. So we can create a last row here, one more row here, and create a sample of differences. So here we created a row which shows the differences. If we denote the population mean mileage before tune-up by mu1 and the population mean after tune-up by mu2, then the difference mu1 minus mu2 we can actually denote that by mu d. So performing the hypothesis test on mu d will be same as performing the hypothesis test on the difference between the means. Let's look at the notation first. D bar is the sample mean of the differences between the values in the matched pairs, and ST is the sample standard deviation of the differences between the values in the matched pairs, and mu d is the population mean difference for the matched pairs. And let's see what are the assumptions need to be checked. So we have a simple random sample of matched pairs. Either the sample size is large, that means greater than 30, or the differences between the items in the matched pairs shows no evidence of strong skewness or no outliers. This is required to be sure that D bar, the sample mean of the differences, will be approximately normally distributed. Now let's look at the procedure for performing the hypothesis using the p-value method. First state the null and alternate hypothesis. Then choose the significant level. Find the test statistic. So this is the formula we are using to find the or computing the test statistic. Then find the p-value. P-value is the area under the t-curve with n-1 degrees of freedom. So left tail test, or if the alternate hypothesis is like H1 where mu d is less than mu 0, that is a left tail test. If it is mu d greater than mu 0, that is a right tail test. And two tail means mu d not equal mu 0. So after that, interpret the p-value. That means we can make decision. We reject the null hypothesis if the p-value is less than or equal to the significance level alpha. So easier to remember, just write it like that. Reject the null hypothesis if p is less than alpha. And after that, state a conclusion. So let's look at this example on does tuning a car engine improve the gas mileage. So first check the assumptions. So in this dot plot there is no sign of strong skewness or outliers. So we can actually proceed. Here the question itself says test for null hypothesis mu d equals 0 versus the alternate hypothesis mu d greater than 0. First, state the null and alternate hypothesis. Step 2, choose the significant level. Here significant level alpha is 0.01. Compute the test statistic. I am going to use the calculator to find the sample mean and sample standard deviation of the differences. So in the calculator, I entered the values in the differences row to L1, and then I press stat calc and one bar stat, and I enter to find the mean and the standard deviation. So this one is D bar because this is the differences. So this is D bar and this one is S D. Okay. So I can use those value here, and N we know that is 8, and mu 0 that is 0 because mu D equal mu 0, that means mu 0 is 0. So let's substitute those values to find the test statistics. So D bar that is 1.20625 minus 0 and enter this into the calculator, you'll get 9.1427. Step 4, compute the p-value. Under the assumption that the null hypothesis is true, the test statistic has a t-distribution. The number of degrees of freedom n minus 1, that is 8 minus 1, that is 7. The null hypothesis mu d is greater than 0, so this is a right tail test. So the p-value is the area to the right of the observed value of, so right side of observed value of 9.1427. This is the test statistic we found. So we are going to calculate the area on the right tail using the calculator. So in the calculator, first press second, then VARS, then select TCDF, then it will give you like TCDF and a parenthesis. So in the parenthesis, write down 9.1427 starting from here to the end. So that is a very large number, so you can enter 10 power 99 and the degrees of freedom 7. Then press enter. So you will get a number 1.92519 then e power, that means 10 power negative 5. That means there will be 4 zeros in front of that. So 0.00001925. So it's a very number close to 0. So this is the p-value. Okay. Now in step 5, we need to check whether p is less than alpha or not. If it is less than alpha, then we reject the null hypothesis. So p we already got that is 0.00001 and alpha is 0.01. So this is definitely smaller than this one. So therefore we reject the null hypothesis at alpha equal 0.01. Now conclude with a statement. We conclude that the gas mileage increased after tune-up. Now let's perform the hypothesis test using the critical value method. So these are the steps. First, state the null and alternate hypothesis, choose the significant level alpha, then compute the test statistic. So almost similar to the previous step, right, up to here. Here we don't need to find the p-value, but we are comparing the critical value with the test statistic. So if the test statistic is less than or equal negative t alpha, then we reject. Same thing if t is greater than or equal t alpha, if it is a right tail test, then we reject the null hypothesis. Easier way to think this is if t is in the critical region, then we reject the null hypothesis, then state the conclusion. Now let's do another example, testing hypothesis using the critical value method. And we can find the critical value from table A3 or with the technology using TI-84 calculator. The assumption for the critical value method are same for the p-value method. Let's look at this example. For a sample of 9 automobiles, the mileage at which the original front brake pads were worn to 10% of their original thickness was measured, as the mileage at which the original rear brake pads were worn to 10% of their original thickness. The table shows the rear and front, and the last line is the different. Can you conclude that the mean time for the rear brake pads to wear out longer than the mean time for the front pads? And we need to use alpha equal 0.05 significant level. So let's first look at the assumption. So step 1, check the assumption. Since the sample size is small, we will construct a dot plot. So the dot plot shows no evidence of extreme skewness or outliers. So we can proceed. So now we need to state the null and alternate hypothesis. So null hypothesis is mu d equals 0 and alternate hypothesis mu d greater than 0. Now choose the significant level. Alpha is 0.05. Because it's a right tail test, because it's greater than 0, so right tail test. And sample size is n equal 9. So degrees of freedom is n minus 1, that is 9 minus 1, that is equal 8. So from table A2 we can find the critical value. T alpha equal 1.860. I'm going to compute the test statistic. So step 3 is test statistic. We can use the formula d bar minus 0 SD divided by square root of n. So we can use the calculator and we can find the mean and standard deviation of these data. So using the calculator we can find that. This is the mean and standard deviation. So use those values. And square root of 9. So test statistic is approximately equal 60.28. So now compare T and T alpha. we reject right tail test, we reject at 0 if t is greater than or equal t alpha. So here t is actually 60.28, which is greater than 1.86. So we can actually reject the null hypothesis. So now we can conclude. We conclude that the mean time for the rear brake pads to wear out is longer than the mean time for the front brake pads. So in this section, you learn the hypothesis test for the difference between two means of paired samples using the p-value method and the critical value method.